Okay, this is the practice test 4A, and the first problem here says the teacher claims that the average grade point average at Potomac State is at most 2.0. Okay, so this is involving the mu, and since it's at most 2.0, that means it's saying that it's less than or equal to 2. Since there's an equal to with it, that would be your null hypothesis that mu is less than or equal to 2. And let me take the underline off of that. That would be your null hypothesis, making your alternate hypothesis, HA, that mu is greater than 2. So that would be the setup of the hypothesis test. And now it says you sample 25 students, that's your N, we have a small sample, N is 25, and find that their average GPA, their X bar, is 2.1 with a standard deviation of 0.9. And it says to use an alpha level of 0.05. So we'll go to the Excel sheet. It's a hypothesis test for a mean, so we'll go to the 1 mu sheet. And let me go to the top of this sheet. And this is a right-tailed test. So right here, we want to put in our alpha level of 0.05, our claim mean of 2, X bar of 2.1, standard deviation of 0.9, and our sample size is 25. We get our test statistic, critical value, p-value, and our decision right here. So we do not reject the null hypothesis on this problem, and that means at the 0.05 alpha level, I was unable to show that the average grade point average at Potomac State is significantly greater than 2, since we did not reject the null hypothesis. On part B, it says run this at the 0.1 alpha level. So all we need to do on part B is change this to 0.1, and it doesn't change anything. We still do not reject the null hypothesis. So since we don't reject it at the 0.1 alpha level, moving on to part C, it says summarize it at the most significant alpha level. So at any alpha level, since 0.1 is the highest you would go, at any alpha level you were unable to show that the average grade point average at Potomac State College is significantly greater than 2. And that would do part C. Part D says to do a 95% confidence interval. So we'll go down here to confidence intervals, put in 0.95, sample size 25, the X bar is 2.1, and the standard deviation is 0.9. You have your t-score, your standard error, which is your standard deviation divided by the square root of n, your margin of error, which is your standard error, times your t-score, and then finally you have your confidence interval here. So we would say that I'm 95% sure that the average grade point average at Potomac State College is somewhere between 1.73 and a 2.47. And I think that does every part for problem number 1. And let's go on here. Problem number 2 says that Nancy heard a claim on CNN that 7% of cat owners buy their cats Christmas presents. Nancy just doesn't believe this claim. In other words, she thinks it's not equal to 7%. So the null hypothesis would be that P equals 0.07 or 7%, and then your alternate hypothesis would be that P does not equal, and I'll have a hard time saying does not equal here on typing it, but it would be does not equal 0.07. So at this point it says she samples 100 cat owners, that would be your N, 100 cat owners, and finds 5 of them, that's your number of successes, do buy Christmas presents for their cats, and says test this claim at the 0.01 alpha level. Well, this is a hypothesis test for percentages, so we'll go to the Excel sheet, go to the 1P sheet, and at the top of this sheet, this is a two-tailed test because it was just she doesn't believe it, so it's a not equal to was the alternate hypothesis, and the alpha level we were supposed to test this at was 0.01. Your claim proportion was 0.07. Your sample size was 100, and your number of successes was 5. That gives you a sample percentage by doing x over n of 5%, or 0.05. Your test statistic is negative 0.7. Your critical values are positive and negative 2.578, and your p-value is 0.4331. Well, since your p-value is greater than your alpha level, you do not reject your null hypothesis. So you would say at the 0.01 alpha level, I was unable to show that the percentage of cat owners that buy their cat's Christmas present was significantly different than 7%. You were unable to show that. On part B, it says check this with p-values. Well, again, since your p-value is greater than your alpha level, you do not reject the null hypothesis. On part C, it says change the alpha level to 0.05, and if you do that, it doesn't change anything because your p-value is still greater than your alpha level. How would you summarize it on a project? Well, even if you check the highest alpha level of 0.1, then you still do not reject the null hypothesis. So at any alpha level, you would be unable to show that the percentage of cat owners that buy their cat's Christmas present was significantly different than 7%. On part E, it says to get a 99% confidence interval. We can do that right here, same sheet, just scroll down to confidence intervals, put in 0.99, 100, and 5. We have our z-score, sample percentage, standard error, margin of error, and here is my confidence interval right here. So we would say that I am 99% sure that the percentage of cat owners that buy their cats a Christmas present is between 0 to 10.6%. And the reason why it's 0 is because you can't have a negative percentage of cat owners buy their cat's Christmas present. So the lowest it could really go is 0. So 0 to 10.6%. F says how many more cat owners would you have to sample to reduce your margin of error down to 1%. Our margin of error right now is about 5.5%, 5.6%, 0.056 is what our margin of error is now. Well, this is a sample size question. So what we do is go down to sample size, put in our confidence level, which is 99%. Our margin of error, it was told how many, the question was how many more do you need to sample to get your margin of error down to 1%. So your margin of error is 1%, and your estimate for p hat right here is your estimate sample proportion right here, 0.05. So that's what you would put in there, because your p hat is x over n, your number of successes over the number of people that you sample, and 5 out of 100 is 0.05. You'll get a total number of people that need to sample of 3,152, but the question was how many more people do you need to sample, and you already sampled 100, so subtract the 100 off of the 3,152 and you get 3,052 more people would need sample. Now part G says if there was no previous estimate. Well, if there's no previous estimate, you can delete this, and it means that you would need to sample 16,588 total. Part H says get a how would you get your sample in some sort of systemized, stratified method. And let's go ahead and get to that here. Right here, some sort of systematic stratified sample, and there you want to use some system where maybe you have lists of at different veterinarians' offices of cat owners, and you pick every 5th person from the list, or use a random number generator to pick what person you're going to choose from the list. And stratified means you might separate your population into non-overlapping groups by perhaps sampling cat owners that are in different locations of a county, or that take their cat to different veterinarians.